Welcome back to Unit 2. We are going to continue on with some more of the basics, and we're going to focus on moles and mass and molar mass today. So again, pages 90 to 95, and in this lecture, by the end of it, you'll be able to define the mole and molar mass, and you'll be able to perform calculations to find molar mass from a chemical formula, and you will also be able to perform calculations involving mass and amount, or mass and moles, for pure samples of matter. So for calculating molar mass, it's 4 steps. The first step is to get the chemical formula for the substance if you don't already have it. Sometimes it's given, sometimes it's not. Sometimes you have to work from the name. Once you get that, you're going to determine the amount of each atom present in the molecular ion. Then you're going to use your atomic masses from the periodic table to determine the moles from the molar mass of the chemical, and make sure that all your answers are going to be to 2 decimal places and the units are grams per mole. So we'll get started. The molar mass for Na2O, or sodium oxide. So for this molecule we have 2 sodiums plus an oxygen. And so we go to our periodic table and we find the molar masses, and so we have 2 ions of sodium, and each ion has a molar mass of 22.99 grams per mole. To that we're going to add 1 ion of oxide, which has a molar mass of 16.00 grams per mole. And then we run it through our calculator. 2 times 22.99 plus 16, and we end up with a molar mass of 61.98 grams per mole. And that's it for a molar mass calculation. That's all you're doing. You're grabbing some numbers off the table, multiplying them by coefficients, and adding them together. So here we have ammonium phosphate. And so just a couple things. When you see this formula, this 3 applies to everything inside the brackets. So it means that there's 3 times 4 hydrogens and 3 times 1 nitrogen. So we actually have to make sure that we multiply that 3 through to every atom inside the brackets. What this represents is an elemental compound where there's 3 ammoniums for every 1 phosphate present in the sample. So we have 3 nitrogens plus 12 hydrogens plus a phosphorus plus 4 oxygens. And then we start grabbing numbers off our periodic table. There are 3 times 14.01 grams per mole plus 12 times 1.01 grams per mole plus 30.97, the molar mass of phosphorus, grams per mole, plus 4 times 16.00 grams per mole. And again, we can run this through. As long as you have a scientific calculator, you can run it through just like that. And you should get 149. So the molar mass of ammonium, and I'm just going to subscript the molar mass like this, phosphate, is equal to 149.12 grams per mole. And by using this symbol, it's as good as using a sentence. Big M means molar mass. Molar mass is represented by an uppercase M, and then subscript it with the molecule you're talking about, and you're done. You're good to go. So for another molar mass, and what I would suggest is, if you want to see if you're getting this, pause the recording now, do the calculation on your own, and then hit play and see if we get to the same answer. So we're going to have a barium plus 2 nitrogens plus 6 oxygens. Remember that 2 applies to every atom inside the brackets. So 2 times 1 and 2 times 3 for those atoms. For barium, the molar mass of a barium ion is 137.33 grams per mole plus 2 times 14.01 grams per mole plus 6 times 16.00 grams per mole. And so the molar mass of barium nitrate is equal to 261.35 grams per mole. And so we have one more here. Here they haven't given us the formula, so we have to figure it out. It's iron 3 hydroxide is the name. So we know it's an iron 3, so it's Fe 3 plus, and it's bonded to hydroxides. And if you take a look at your table of common polyatomic ions, hydroxide is OH. It has a negative charge, and then to find our formula, we just take the charge and put it as the subscript to the other atom, or the number from the charge. So 1 for iron, 3 for hydroxide, and so it's Fe, and then in brackets OH 3. And so we have an iron plus 3 oxygens plus 3 hydrogens. The molar mass for iron is 55.85 grams per mole plus 3 times 16.00 grams per mole plus 3 times 1.01 grams per mole. And when we run it through, we should find that the molar mass of iron 3 hydroxide is equal to 106.88 grams per mole. Alright, so if you're given a mass, we're going to do some mass amount conversions, or once we have a mass, we usually want to find out the number of moles of something that we have. So we're usually going to be given a mass because most of the time you can take a substance, you can put it on a scale, you can see what its mass is. Next step is to calculate how many moles of it you have. So to calculate moles, you simply manipulate your formula. This formula here is your base formula for molar mass. Its big M is molar mass, and it's measured in grams per mole, which is, grams is a mass of something, and the symbol for moles is an N because it's an amount. So that M over N just comes from the units of molar mass. It's the number of grams per mole of substance. Based on that formula, you can manipulate it and isolate the number of moles. If you're given the amount, so if you're given the number of moles, you use the same formula. You're still going to have to find the molar mass from your periodic table, and then you can calculate the mass of a substance using the same formula. So I always remember, this is the part that I memorize. I memorize this formula. It's not written down in any of your data booklets, so it's important that you have this memorized. I mean, you can always have it down on a cheat sheet or whatever, but the less stuff you have to write down and look up, the faster you can work. So molar mass is equal to grams per mole. It's equal to mass over moles. And then to manipulate it, you just multiply both sides by the number of moles. For both formula manipulations, here's just a quick review. When you want to isolate mass, I find the easiest way to do it is multiply both sides by the N, by the number of moles, and that way, I'm just going to go through here, hold on. Okay, so when you multiply both sides by the number of moles, on the right side, moles cancel out. That isolates M, but you want it to isolate N. So the next thing you're going to do is divide both sides by mass. Oh, but Jesus. Okay, so for formula isolation, if you need to isolate mass, you're going to take your formula and multiply. There's my mouse, there it is. You're going to take your formula. To isolate mass, you want to get mass by itself, so you're going to multiply both sides by the number of moles. What that does on the right side is your n's cancel, because you have n over n, that's the same as 1. And so you isolate mass, and sometimes if you want to rewrite it by switching sides just so it looks prettier, it means the same thing, so both things are acceptable. When you want to isolate moles, I follow the same set of steps. I isolate my mass first. So here's the formula that I start with. It's kind of your default. Multiply both sides by n. They cancel on the right hand side. And then to get that n by itself, we're going to divide both sides by big M. So when we divide both sides by big M, it cancels on the left side, stays on the right, and so number of moles is equal to mass over molar mass. And so I always find it easiest just to memorize our default formula and then manipulate it as you need to isolate the variable you're looking for. So here we want to convert 1.5 kilograms of calcium carbonate, so we have a mass of calcium carbonate to an amount in moles. So we're looking for N, and we can always find the molar mass. And we're looking for the molar mass of calcium carbonate. Calcium carbonate is CaCO3. So we can find the molar mass of calcium carbonate it has. And so we'll find that first. And once we find the molar mass of calcium carbonate, then we're going to use our molar mass formula to find the number of moles. So first, the molar mass of calcium carbonate, we have a calcium plus a carbon plus 3 oxygens. The molar mass of calcium is 40.08. Plus 12.01 grams per mole for carbon, plus 3 times 16.00 grams per mole. We're going to run that through our calculator. And so we find the molar mass of calcium carbonate to be at 100.09 grams per mole. And now we can use that number in our molar mass formula. So we want to isolate, we want to find moles. So just beneath it here, I have molar mass is equal to mass over moles. I want to isolate my moles, so I'm going to multiply both sides by moles. It cancels on the right, and I have N big M is equal to little m. Divide both sides by big M, and so the number of moles of calcium carbonate is equal to mass over molar mass. Plug in my numbers. My mass was 1.5 kilograms, which is 1,500 grams. I want to make sure my units match. So since I have grams in my molar mass, I want to have grams in my mass. So 100.09 grams per mole. Do the division, and we get 14.986. So 14.9865 moles. We only have 2 sig digs, so our answer is going to be 15 moles of calcium carbonate. And that's how we do it. We find the number, we find the molar mass using our periodic table, and then manipulate our formula, plug in our numbers, and get an answer. So here we're given an amount of sodium sulfate. So we have the number of moles of sodium sulfate. We want to find the mass in grams. So we have N of, and sodium sulfate is Na2 SO4. We're looking for mass, and we can always find molar mass we have 2 sodiums plus a sulfur plus 4 oxygens. And so we got 2 times 22.99 plus 32.07 plus 4 times 16.00, and when we run it through we get 142.05 grams per mole. And now we can use our molar mass formula. So we know molar mass is equal to grams per mole, or mass over moles. We're looking for mass, so we're going to multiply both sides by n. They cancel on the right hand side, and we have molar mass times moles is equal to our mass. And so that's the version of the formula we're going to use. So the mass of Na2SO4 is equal to the molar mass, which is 142.05 grams per mole, times the number of moles, which is 0.346 moles. And so we get 49.1493, and our moles canceled, so our answer is in grams. And then we go through and check our sig digs. We're allowed 3 sig digs, so 49.1 grams. And for our last example, we have to convert 75 milligrams of chromium into an amount of moles, chromium sulfide. So, again, they didn't give us the formula, so we're going to have to figure it out for ourselves. Chromium 3 is the ion they're making us use, so it's chromium 3 plus. Sulfide is the sulfur ion, and so it's S2 negative. Switch your charges, and you get Cr2S3. And so, since we have it, usually what I do is I find my molar mass first if I know I'm going to need it. So I know I'm going to need it 3 times. We have 3 chromiums plus 2 sulfurs. The molar mass of chromium is 52, so 3 times 52.00 grams per mole plus 2 times 32.07 grams per mole. Run it through our calculator and we get 220.14. That's grams per mole. So now we have the molar mass. We'll haul out our molar mass formula. And we are looking for moles. So we're trying to find N. So our molar, so we're going to multiply both sides by N. Cancels on this side. We get N, M is equal to mass. And divide both sides by molar mass. And so N is equal to mass over molar mass. Our mass is 75 milligrams, which is 0.075 grams, divided by 220.14 grams per mole. So we get 3.41 times 10 to negative 4 moles. And that would be an acceptable answer. So this would be the N, or the number of moles of chromium 3 sulfide in 75 milligrams of chromium. I always find it easiest just to convert to your standard units. And just a quick way to show you how I do it. If I have milligrams, in order to convert it to grams, I use what's called unit or dimension analysis. We have 75 milligrams, and we know that we want the answer in grams, so grams has to be at the top of our ratio. So we're going to multiply by 1 gram over, and there are 1,000 milligrams in 1 gram. And so since I'm trying to get rid of milligrams, I'm dividing by the milligrams part. Our milligrams cancel, and so what I'm actually going to be doing is just 75 divided by 1,000, and I'm multiplying that by 1 gram. And that's how I get my 0.075 grams. So for homework, give question 5 and 6 a try on page 95. And also try out the skill quiz number 6. Skill quiz number 6 is all molar mass using your periodic table. Knowing your chemical formulas, being able to find molar mass is crucial to the rest of both this chemistry class and chemistry 30. You need to be able to find the molar mass of any given chemical, and you need to get it right every single time. So skill quiz 6 is just getting you to build up that ability so that you don't get the question wrong before you start it.